thanks for coming. Hopefully you'll find this session valuable. And I believe I have 30 minutes. I'll leave about 5-7 minutes at the end for questions. So, in the middle, if you have a question, feel free to interrupt if you have a quick question, or we can do it at the end. So just as a way of introduction, Anthem, we are the nation's second largest health insurance company. And we serve 1 in 8 Americans. Our membership is about 45 million people. And through our subsidiaries and all that, we serve about 117 million people across the country. As just in terms of revenue, we are about 120 odd billion. So we're Fortune 20 company. And just from a scale standpoint, we process anywhere between 700 to 800 million claims on an annual basis. So that sort of tells you our scale. And we are in almost 25 states across the country. So we serve almost 50% of the country. 14 of those are really states where we are blue branded, and 25 others where we do business as Medicare, Medicaid, those kinds of things. We also have some international presence in Puerto Rico, we have a global presence in Ireland as well as in India. We have captive companies that we work with, globally as well. So that's our mission is really improving lives and communities and simplifying healthcare. And our vision is to be the most innovative, valuable, inclusive healthcare company. So the goals for serving our customers are really, if you think about, in this day and age, where the consumers are used to simplicity and digital experiences and things like that, right? So that's really our goal, is to use data and analytics to drive the experience for our members and our employer groups and the providers and the doctors and the hospital systems that we work with. Increase the quality of care for our members, and do that at a cost that's we keep driving down, again using data and analytics. Use advanced machine learning and AI and data science techniques to use the data, leverage the data to do that. And then we've been building a lot of health-focused apps. So we have an app called Sydney that's on tens of millions of handheld devices that our members download. Again, a lot of those things are sort of driven by data and analytics, and I'll kind of talk through how we're doing that, and what our journey looked like in the past 3-4 years with AWS. So from a if you think about so I run data for the company from an analytics perspective. So this session is going to be focused more on data and analytics. So what's the from a data standpoint, the biggest challenge the past few years has been around data engineering, right? So if you think about 10-15 years ago, lots of companies had data warehouses and things like that, and they did very well using those. But then around the early 2010s, mid 2010s, data started exploding, right? With device data. If you think about healthcare specifically, clinical information, a lot of unstructured data. Medical records, things like that, imaging, call center data. There's lots of this kind of data that started exploding, and that's when that coincided with the big data sort of revolution or evolution, or whatever you want to call it, right? And like most companies, Anthem invested heavily in big data technologies, and we've had some great success with that whole stack. Especially from a data science, AI, and machine learning kind of standpoint. But the promise of big data and the open source stack to sort of become the data platform for all things never materialized, right? While we've had some strong successes, like a lot of companies, we've struggled with getting value out of our Hadoop and big data investments. And you could put data in very easily. Getting value out of it was extremely hard, right? And as our data started growing, we were really at this juncture where we were not getting value out of big data and Hadoop. And then our data warehouse was great at running certain workloads, but it was not great for supporting all the new workloads that were coming in. So we really had to make a decision around how we're going to support all these things going forward and how we're going to become this innovative company that we want to be, the digital company that we want to be, right? And that's when we really started looking at the cloud and investing, and we partnered with AWS at that time. So right before the pandemic, sometime in the 2019 timeframe is when we really started engaging with AWS. And the approach we took was, I'm sure many of you have heard the term data has gravity, right? So where the data is, workloads tend to go, right? Data tracks workloads and use cases. So we started from, what's our most valuable, highly used data, right? And we started to, sort of think about that and how do we, sort of make that migration of that data to the cloud, as efficient as possible. And then the workloads will follow, right? So that was our approach, and we did that. So right around in the middle of 2019, when we started engaging with AWS around, what are the platforms we need to use, what are the technologies that we can leverage, things like that. But then we also had, as a highly regulated healthcare company, we have a lot of requirements around data protection, data security, things like that, right? Privacy and all that. That's very important to Anthem. So we spent a good amount of time in the beginning stages working with AWS to sort of build a lot of those capabilities, right? Before we couldn't really move our data to the cloud just like that because we're a regulated entity and it takes a lot of work to protect our data. So we spent a good 6 to 12 months sort of building all those capabilities around securing data and all that. And then right around the time the pandemic hit, we started building this what we call a data platform, right? And that data platform, I'll talk a little bit about more details about what that entails and how we went about building it, right? So really, the platform is essentially a framework that combines data acquisition, data movement, protection of that data, how do you transform that data, DevOps, and then essentially making that data seamless and very easy to consume for all sorts of use cases, right? So we really, our goal was, first came the data warehouses, then came the data lakes, and then now you hear this term called, lake houses, right? People combine data warehouse and data lake and call it a lake house. All that terminology aside, our goal was to bring all that data together into a single location, single platform, but also ensure at the same time that that data is not locked into any one particular technology, right? Because that's what kills use cases. So bring the data to the cloud, make it all available in multiple formats, in multiple technologies, so that depending on the use case, you can drive the use case to the appropriate technology. So that was sort of our mindset going in. And this data platform, really, we had 4 goals. One was, like any company, we are on this journey to get to the cloud, right? It's not something that's going to happen overnight. So we're going to be this sort of, in this hybrid state of, certain things will be in on-premises in data centers, certain things in the cloud, and the gravity will shift more to cloud over time. So, but in that time frame, you have to have really, ability to transfer data at very rapid, high speed. Between our data centers and cloud and back to the data centers, things like that, right? So that was one of our key tenets. And then also, provide a simplified data engineering platform, right? That really simplifies, for application teams on how they bring data to the cloud, how they interact with that data, things like that. And then, build that platform in such a way that it's, completely metadata driven to the extent possible, so that it's a completely low-code environment. All the work for data transformation and all that is done through configuration versus hand coding and things like that. So that users or developers with little to no ETL experience will be able to move data quickly as well. And then also protect that data in that process, right? Encrypt that data, tokenize certain things, because that's a big requirement for us. And then, once the data is there, how do you rapidly build and, analytics at scale, right? Whether it's data science, AI, ML, enable easy access to that data, right? Self-service kind of. So those were sort of our goals. And then from a core principle standpoint, I talked about a lot of these already. right? How do you streamline, data acquisition and all that? And then, also, how do you do metadata-driven, development, things like that? So I, kind of went through this already. Provide APIs, and then provide a, easy-to-consume, data catalog and things like that. And then also the other, big thing for us is, besides the data that we have a lot of, other, third-party companies that we work with that we want to integrate into our platform, right? So the way we do that is really through our, we're working on a, another product called Health OS. So that Health OS is really health operating system. That's really a way for us to connect with, our provider groups, our hospital systems, things like that, make the interaction seamless, those kinds of things. And then also bring innovative companies that have products and solutions that they can deploy quickly on our data. So how do you plug them into our sort of data ecosystem quickly, right? So those are sort of our core principles of how we built this platform. And then really, so that's really the summary of what we call our Anthem Enterprise Data Lake. This is really our data platform. So if you typical diagram going from left to right, right? So we have all the data sources that we collect data from. These are literally hundreds, and thousands of data sources that we acquire data from, internal, external, social data, all kinds of stuff. And then all that data is aggregated on premises within our on-premises environment, right? Whether it's the data warehouse, data lake, or clinical data platforms, things like that. And then how do you surface that data quickly? So we are in this hybrid state where a lot of the data gets generated on premises. And how do you take this data and surface it in the cloud for easy consumption, right? So if you look at the current state challenge I talked about early, some of the data is in the data warehouse, right? Some of the data is in our Hadoop data lake. And it's very hard to move data across these two things, especially in a data center, right? And we're talking petabytes upon petabytes of data. So we have a huge engineering challenge in managing all this data. And then when a particular use case comes up, well, where is my data? Is it in the data lake? Is it in the data warehouse? Is it somewhere else? How do you bring all that together, right? So that's where really the cloud comes in, where we've built this, taken all this data through this pipeline that we've built that's completely, sort of metadata driven. And if you really look at that metadata-driven framework in the middle there, that's essentially our framework that takes all this data and then natively integrates it into the cloud using a completely metadata-based approach. I have a next slide. I'll kind of a little bit more detail about how that happens. So whether the data is, we're batching the data or streaming the data, as soon as it lands in an S3 bucket, from there, it's just a matter of configuring, what that data is, where it's coming from, where it needs to go, what needs to happen in the middle. All of that is entirely metadata driven. And once you set up the configurations and parameters like that, the data, whether it's, it's time-based or event-based or whatever, the data comes in, it gets processed and, gets surfaced into, so you see some, technologies there. We use Redshift for certain use cases. We use Snowflake for certain use cases. And then once you sort of integrate all that data, you have to build features, right? You have to do a lot of feature engineering to do data science predictions and things like that. A lot of those kinds of things. We've built a data sandbox. And then I mentioned Health OS a little bit, right? And we also have some use cases where, we want extremely low latency kind of applications. We use, search-based things like Elastic and, those kinds of things. So all of that, what the cloud has really done for us is two things. One is bring all the data together. In the past where the data was kind of spread all over the place, it was hard to integrate. The cloud has enabled us to sort of bring all that data into a single place and then surface it in any technology that you want. Relatively easily, right, without having to incur a lot of penalty on, network transfer costs and these sorts of things, and use a lot of open source sort of data, formats to make that easy, right? So, for example, once the data lands into our enterprise data lake, which is really built on Snowflake, and by the way, Snowflake is a great partner with AWS, and they've collaborated really well to to give us the solutions we need, right? So there, when Snowflake, we decided to invest in that platform, AWS and Snowflake had to do a lot of engineering together to, so there have been, so we're using not just AWS native stack, but where it makes sense, other AWS partners as well, right? So really, that's essentially what this data lake has done for us is, make the data accessible to any and all use cases, right? Whether it's data science, AI, machine learning, your typical, BI, dashboarding, reporting, we're able to do all that from a single platform. And it's all driven through this, metadata-based approach. And if you look at this, all the tokenization and all that, again, that's a data security requirement that we have, and all that happens sort of in a seamless sort of manner through our metadata framework. And this is sort of a little bit, more detail on, how that ETL orchestration happens. And this is really, if I have to kind of summarize how we've been, successful with, getting to the cloud quickly in a couple of years, taking all our data, kind of moving that gravity easily to the cloud. It all goes back to this sort of ETL framework and orchestration framework that we've built, right? This audit and control database thing you see here, that's really the nerve center of where all the configuration sits. And then whether the data is coming through, events or files or triggers, what have you, all that orchestration happens through, the AWS Lambda functions or so all the configuration data is read through these, AWS services, microservices. And then the ETL orchestration pipeline, uses, whatever, technologies it needs. For example, if there's some ETL, leverage glue. We do a lot of our ETL, ELT. So we want, once the data is pushed into, the target data platform, even that ETL gets orchestrated through this. And then once the data is, published into the data lake, if it needs to go to, again, the raw data comes in, it gets standardized, you do something to it, and then you surface it, in something like an S3 for running some large machine learning jobs, right? Because that's the right technology for running those kinds of, things. So all that sort of happens through this metadata framework. And just a little bit of, the cloud journey. Like I said, we started sometime around 2019. And really, as the pandemic sort of went up, the graph, you can see that our adoption of the cloud also sort of, took that same curve. And that, at the top, you see where we are today, that, that graph really should be like that. Because, in 2020 and early 2021, that's when we built this whole ingestion framework. And that has enabled us to, just within the last, 9 to 12 months, take 50, really large applications or, slash capabilities to the cloud. And we have, a large plan over the next 12 to 18 months to sort of move a lot of our core analytic, processing and capabilities to the cloud. And the reason we're able to do that is we invested in this framework, and, that's sort of what's been very helpful to that. And through this journey, really, we've partnered very closely with AWS, and they've been great help in making this happen. So to summarize, right? So why AWS? Why did we choose AWS? Obviously, one, as I mentioned, scale. With really, in the past, we struggled with data in different silos and on-premises, and that's just the limitations of on-premises technologies. So sort of the cloud with its separation of storage and compute, those kinds of things, it's really given us the ability to scale to our requirements. Obviously elasticity, things like that. Performance when you need it. Security is a big thing for us. We invested quite a bit in that. Managing the cost, as well as leveraging the whole AWS service stack for AI and machine learning, things like that. We're leveraging other healthcare specific capabilities that AWS has, things like AWS Health Lake, and then we're also working on a lot of another example is AWS AppStream, that we've spent a lot of time with AWS in kind of building that AWS AppStream as a sort of a desktop for all sorts of user personas, right? Whether it's a casual business user, to all the way to a very talented, highly technical data scientist. So how do you give them the desktop experience they want? Having notebooks and all those sorts of things. All the tools that they use on a regular basis. So we've invested in a lot of those kinds of things. And then leveraging a bunch of healthcare specialized services from AWS. So all that put together is really how we've been able to move the needle on improving our analytic capabilities, and that's our that's kind of been our journey over the last 2 years, 2 to 3 years.
Why did you choose, or what was your decision making for choosing Snowflake over Redshift?
Yeah, so I think it's a few things, right? One, I think Redshift we found it works really well for a certain type of use cases and personas, and Snowflake we felt was a better fit for certain types of use cases, right? And the other thing is we're also just like we're working with AWS, we're also working with other cloud partners, right? So there are use cases where we have that are going to be deployed in other platform, other hyperscale environments. So that's another reason.
Do you actually use it across the different cloud providers?
Correct. Yeah. So a couple of things. One, there are certain business units that have chosen Redshift as an example, right? And it's because their use cases are a better fit for Redshift, and they've chosen it, and that's one. And the second is really where where Snowflake really fits is if you want to call it a data lakehouse, right? That's the really having all our highly valuable conformed data, raw data, right? Pulling all that together into a single environment. So that's where we're really leveraging Snowflake. And then, for like if you have for example, some kind of deep learning use case, things like that, right? Redshift might be a better fit for that, right? So Snowflake really gives us that ability to, really truly separate compute and storage, and apply, specific workloads with specific compute. Yes. Sure. So we use Informatica data catalog. We've been using that product for many years on premises, and so it just made sense for us to leverage that same platform because we've so much invested in it, and really everything that goes into our any data environment, right? It's a requirement to have metadata all documented well, including the ETL transformation rules and all that. So it's our single source of information for anything around data, what where it's coming from, where it's going, what's happening to it, all that kind of stuff. This was prior to the migration, and we already had a big investment in it, and so it just made sense to start to extend that to the cloud as well.
Yeah, digging deeper into that Snowflake decision and the users that are using, are you exposing it outside of your IT user group, or is it something that the business is also using? I know Snowflake has a good interface for that.
Correct. Yeah. So our business users are heavily access our data environments. So we have essentially 2 or 3 patterns, right? One is users accessing the data through an application layer of some sort, right? Whether it's a BI application or a visualization tool or those kinds of things. And the second is, I think those serve a certain amount of use cases, right? But there'll always be a need for business users to do ad hoc access to the data, right? And so we do that in a controlled manner. So that's where business users do have access to the data environments directly, but we manage that very closely so that it doesn't become a self-service is a great thing, but you want to make sure that it doesn't become a huge problem in the long run, right? So we really manage how they access it and things like that. And then that's where you can really really set up different compute clusters for user groups and have them sort of be separate from each other so they're not stepping on each other. A lot of these challenges, that's the other beauty of the cloud, right? Is you couldn't do these things in the past. In the past, we've always struggled with when you have all sorts of use cases trying to work within the same environment, managing those workloads from an operational standpoint is extremely difficult, right? And that's the other huge benefit that we've experienced from the cloud is really having that workload isolation. That's been like a huge enabler for us. Yes.
You mentioned earlier that you have like 6 700 million claims that you process annually. Can you talk a little bit about what you do in regards to data accessibility, like older data versus newer data, like current data?
Sure. So, obviously there is always this tension, between, from a regulatory standpoint, how much data you want to keep, you can keep, to how much data are the data science teams and all these entities, they want to hold on to as much data as they can, right? So there's always this tension. So the way we manage that is we maintain a certain amount of data in our live environments, and then the rest is archived to object stores and things like that for, and then those are very tightly controlled, right, in terms of who gets access to it, what they can do with it, things like that.
So you mentioned about the data engineering challenges, right? Do you keep your data engineering team centralized or decentralized around the business unit?
So the team that's building the platform is centralized, right? So it's a core set of engineers that that build all these capabilities around. Essentially their job is to make the platform sort of flexible, right? And then so that other data engineers outside of our groups can then leverage those capabilities to rapidly do what they need to do. So we have
Decentralize the infrastructure team, but then other data engineering team.
Correct. So other application teams, they might have their own data engineering folks, right? But they'll leverage with the platform and the capabilities and the technologies that we've built to fast track what they're doing.
I hear that you started a long journey around 2019 migrating the databases. Can you share your experiences about the historical data? How different was it? How much was it? And any learnings from that? How you migrated from the legacy systems to cloud and Snowflake?
Sure. Yeah. So I think it's really two things, right? So we still have some of those legacy systems because migrating off of those legacy, like a data warehouse, for example, right? Migrating off of that is that's a multi-year journey, especially because that those things are really ingrained into our business and they run a lot of core business functions, right? So that's why we took a really a conscious decision to actually migrate that data and surface it in the cloud so that it's accessible to broader use cases, right? So while we may still have the legacy, environments, now we have this data also available in a modern platform to drive all the new use cases, right? So that's one thing I want to make sure I call out. And then from, how do you take this petabytes of information and, get it to the cloud, right? That was we had to invest initially a lot of time and energy on how to make that happen, right? So using the AWS's various mechanisms to transfer large amounts of data on devices. So that's what we've used to do the initial one-time migration of that data, and then from that point on, it's all over the wire.
Was unstructured data part of this implementation?
Absolutely. So an example is a couple of examples, voice transcripts and things like that from call centers. And then clinical information, right? So those are two good examples of unstructured information. And yeah. Yes, sir.
Can you elaborate a little bit on security and do you have any Medicare or Medicaid data?
Yeah, so absolutely we have Medicare and Medicaid data in there. And so Anthem has always been sort of, we've had these requirements around certain data sets can only be touched by people that are onshore, right? As an example, you can't do certain functions offshore. So all those sort of requirements carry to whether they're on-premises, cloud, doesn't really matter. And we've built sort of metadata based solutions for that as well, right? So so for example, if you're an offshore person, certain data sets are completely like walled off from people, right? So and all that again is done through our metadata based framework.